Hello and welcome to my kitchen again. Was that as creepy as I had hoped it would be? All right, let's have some fun. We're going to review quickly exergonic, endergonic, exothermic, and endothermic. Before we get started, I'm going to do a quick homemade reaction. We're going to bust apart a cold pack. If you remember, on Friday we took apart a hot pack to see what was inside of it. Today we're going to take apart a cold pack to see what is inside a cold pack. I haven't tested this out because these are expensive, so hopefully this works well. If not, I will stop the video and act like it never happened. So we're going to open it up, and we have this, and we have wow, it's hard to see. We have these little pieces of salt, these little salt pieces. It looks like little fat salts. It's actually ammonium nitrate. And you know how to write that. NH4 is the ammonium part, and nitrate is NO3, right? So this is ammonium nitrate. It's little white pellets found inside your ice pack. We also have this little package of something here. This would be good old-fashioned water. So I'm going to take this, and I'm spilling it all over my kitchen. I'm going to take it, I'm going to mix it together, and mix it around. This is already getting really cold to my hand. This container is getting cold to my hand. I'm going to put the thermometer in there. Right now the thermometer is reading, it's going fast. Going down fast. Right now it's 53, so we're 53 degrees Fahrenheit. Sorry, I don't have it in Celsius. It's 53 degrees Fahrenheit right now. We're going to come back to it later and see what the temperature is, and I already can tell you it's going down because this is a super cold container. I'm going to put this right here on my computer so I don't forget to come back to it. And let's hope I don't spill that on my computer, or I will be crying on this video. Okay. Reactants are all the chemicals that we start with, and then we take all those atoms and rearrange them into the products. Right? The first example is if I happen to put heat. Imagine this is attached here, but I don't have enough space. So imagine I have heat in the reactant. That means that heat has come from somewhere, come from the environment, and has come into this reaction, into the system. Oh, my dog is thinking I called him when I whistled. That's great. All right, so heat has entered into this reaction. It came into this reaction. So I'm already going to pick up my N prefix. I also know that the word heat is, another word for heat is thermic. So when heat is on the reactant side of a chemical equation, it is a endothermic. You're missing an O there, but endothermic reaction. Endothermic reaction. If I happen to put the heat as a product, that means the heat is exiting. We started with something, we rearranged the atoms, we ended up with something new, and heat has exited. We know that heat didn't just stay in one place. It goes from hot to cold and not the other way around spontaneously, right? Heat goes from hot to cold spontaneously and not the other way around. Remember that from first semester? Laws of thermodynamics. So heat is exiting the reaction. It's not just going to sit here in the product, it's going to go away. It's exiting. So heat is in the products. If heat is listed in a product, it is exiting. It's an X. And we know that heat means, another word for heat is thermic, so it's going to be an exothermic reaction. Exothermic. If heat is in the products, it's exothermic. Well, sometimes we don't use thermal energy. Sometimes we have light or electrical or acoustic or sound. Let's say we have energy entering into the reaction. These guys are coming to the party. In fact, we're asking it to come in. These reactions can't even happen without energy. So if it's requesting energy and energy is coming into the reaction, first of all, we're going to use the N, right? It's going to be into it. And another word for energy, we know that energy and work are kind of related. And the word gonic means work. So they're both measured in joules, right? Energy and work are both measured in joules. So we can kind of use these words interchangeably. So if we have energy entering in the reaction, we're going to say we're going to entering in the reaction, and it's energy or ergonic. So if it is a endergonic, this will be an endergonic reaction. Energy's in the reactants. It's entering into the reactants, into the equation, so it's endergonic. All right, what about energy that's being given off, like in a Bunsen burner or something, right? And this is not just heat energy, it's light or electrical energy. If energy is in the product, anytime you see energy in the product, that's going to tell you that energy is actually exiting the equation, right? So it's being given off. So we're going to use exit because the energy is exiting, and we're going to use organic for energy. So it's going to be a exergonic reaction. Exergonic reaction. I think Luke brought this up. So this is the way you're going to see it as it relates to IPC. But Luke did mention sometimes you see the word heat above a reaction. And that does tell you that heat is being applied to this situation. But for purposes of classifying this reaction, let's clearly put heat as a reactant or clearly put heat as a product. Sometimes you even find a catalyst written above the yield sign, which isn't even involved in either reactant or the product. So let's just not put anything above there for purposes of classifying these reactions as endothermic, exothermic, endergonic, and exergonic. All right, so I also strategically put some words over here on my oven. If you remember when we did something previously, my oven, here's the word in. Wow. This was on my oven because when any type of reaction that you're cooking, you're putting heat into that food. You put cookie dough in the oven, it's not going to cook itself, right? We need to put some heat into it. So cooking reactions or examples are always going to be endothermic. Over here on my stove from the other day, if you can see this, I have the prefix X because when you have a flame, like when I lit my gas stove, when you have a flame, you're giving off heat and light, and those types of reactions will be exergonic. All right, let's check back in with my. You're not going to be able to see it, but it's just a little slurry of it's just a thick white. You can't see that without me making a mess. Anyway, trust me, it's thick and it's white and it's not transparent. It's not. Can't think of the word. It's cloudy. It's cloudy. That's the word I'm trying to think of. It'll work. But now we're at 39 degrees. We started at 50 something and now we're at 37 degrees. So how in the world is this reaction occurring? It is pulling heat from my kitchen. It's pulling heat, or another word for that is therm, it's pulling heat from my kitchen in to these chemicals here, into this reaction. So it's endothermic reaction. And if you want to see what that looks like written out, it will look something like this. Hope you can see that. Ammonium nitrate, and this plus, it's written kind of odd because I couldn't squeeze it all in the same line, but it's ammonium nitrate or plus water yields ammonium nitrate ions and ammonium ions and nitrate ions and water. And this should actually be written in an aqueous solution. And we should indicate that these are an aqueous solution, but I just put water. So it's going to take energy. So we know that this is an ionic compound, and those forces are keeping the compound together. It's going to take energy to help the polar water to go and kind of wedge in between ammonium and nitrate. It's going to take energy to break those jokers apart. And that energy, is coming from my kitchen. The thermal energy and that heat from my kitchen is coming in. And that's why my kitchen feels colder. And that's why this container here feels colder. It took the thermal energy from this container and it went into the chemicals. And that's why this feels cold. because it lost some thermal energy. So there you have it. I hope this helps. I'm going to put some practice problems at the end of this video for you to practice classifying reactions as endothermic, exothermic, endergonic, exergonic, and I hope that helps.